Hello. In this recording, we will be making an introduction to project management. Time to time, I'll be starting PMF lectures by using famous quotations which I feel are relevant to the topic. This week's quotation is from Winston Churchill. He says, "Success consists of going from failure to failure without loss of enthusiasm." Here are the expected learning objectives for this unit. On completion of this Unit 1, you should be able to give a concise definition of project management, discuss possible trade-offs when trying to optimize project cost, time, quality, and requirements, explain what characteristics make a project, and outline several different ways of classifying projects. Reflect on the origins of project management and highlight a few early developments in the field. Debate the nature of project success and failure and explain why accurate statistics are difficult to obtain. Identify some key differences between software and other engineering disciplines and management implications. Before deep diving into the area of project management, we should first seek an answer to the following question. What is a project? The British Association for Project Management, APM, in 2019 gives the following definitions. A project is a unique, transient endeavor undertaken to achieve planned objectives. A program is a group of related projects and change management activities that together achieve a beneficial challenge for an organization. A portfolio is a grouping of organizations' projects and programs. Portfolio can be managed to an organizational or functional level. And project management is the application of processes, methods, knowledge, skills and experience to achieve the project objectives. British Standard BS 6079 2019 defines a project as unique process consisting of a set of coordinated controlled activities with start and finish dates undertaken to achieve an objective conforming to specific requirements including constraints of time, cost and resources. And project management as planning, monitoring and control of all aspects of project and the motivation of all those involved to achieve the project objectives on time and to the specified cost, quality and performance. Similar definitions can be found in publications relating to British Prince 2 method and of the American Project Management Institute, which is PMI. It should be acknowledged that the more of the following characteristics that are present, the more likely we are to regard something as a project. The need for planning, the non-routine nature of tasks, having a predetermined time span, having specific objectives to be met, work being executed in phases, work being carried out for someone else, work involving several specialists, constrained resources, being large and/or complex. As we now are capable of defining a project, let's take a snapshot of past projects and modern world projects. First example is the Great Pyramid of Giza. The man-made pyramid requires 20 years of labor and architects dedicated to each of the structure's 4 sides. The pyramid would become the first and the only one of the 7 wonders of the ancient world to remain most intact. The other example is the Great Wall of China. Emperor Qin Shi Huang orders the project's labor force to be organized into three groups: soldiers, civilians, and criminals. Another example is the Industrial Revolution. US business leaders balanced the management of both manual labor and mechanized manufacturing. The other example is the Transcontinental Railroad, one of America's greatest technological feats. The railroad that connects California to the eastern US becomes one of the first government projects that require large-scale project management by railroad pioneers. Well, we are now capable of defining a project, and we have seen some examples, but hey, how these projects are managed, what methods are used, what techniques have been used. Let's have a snapshot of the evolution of project management techniques. For the first time in modern world, in 1896, a Polish economist, Karol Adamiecki, creates the harmonogram, a floating bar chart used to show tasks or resources laterally over time. It is limited to Polish speakers only. In 1912, Gantt chart has been invented. Engineer Henry Gantt develops the Gantt chart, a diagram that breaks down tasks into clearly designed schedule structure. It was first used in World War I to develop building ships. It was used again in 1931 for the Hoover Dam. The method is still being used and applied in organizations today. In 1954, US Air Force General Bernard Shreve coins the term project management for the first time. In 1956, the American Association of Cost Engineers, AACE International, is formed. A well-known method, which is the critical path method, CPM, was invented in 1957. DuPont and Remington Rand designed this method, which calculates the activities required to complete a project and the duration of each phase. To manage chemical plant maintenance, the project saves the company $1 million in its first year of implementation. A year later, the method Program Evaluation Review Technique, PERT, has been invented. PERT was developed as a part of US Navy's Polaris missile submarine program, and this approach analyzes the task type and minimum amount of time needed for each task. In 1962, Work Breakdown Structure, WBS, was invented. The US Department of Defense creates the method to break down projects into smaller components and organize them into hierarchical tree structures. The model focuses on what needs to be done, not the time for it. In 1965, the International Management System Association, known today as the International Project Management Association, is founded in Europe. In 1969, the Project Management Institute, PMI, is launched to promote project management as its own discipline and profession. Professionals can receive specific certificates through this program, including Certified Associate in Project Management and Project Management Professional. In 1970, the waterfall method has been invented. Winston Royce creates a model whereby each phase must be completed and perfected before moving on to the next level. Projects are diverse and the techniques and issues addressed by project management are not equally applicable to all projects. It is therefore useful to classify projects so that the characteristics of various project types can be discussed. There are a number of ways classifying projects. GMPP projects are classified into one of four useful but not exhaustive categories determined by the purpose and nature of their delivery. The first one is transformation and service delivery that comprise work practices and systems. Second one is the information and communication technology (ICT) that covers bespoke and legacy systems. Third one is the infrastructure and construction that comprise utilities, transportation, and buildings. Fourth one is the military capability that covers new equipment and systems. Obank in 1994 suggests the classification of projects into four types depending on how much you know about what you wish to achieve and how sure you are about how you are going to do it. In open projects, you are unsure of what is to be done and how you are going to do it. Obank likens such a project to walking into a fog. In semi-open projects, you know how the project should be conducted, but not sure what is to be done. Just an example, developing a product to make use of new technology or to make use of spare machine capacity. In semi-closed projects, you know the what, but not the how. These may be based on an attractive goal, such as development of an electric car. In a closed project, you know both the what and the how. Traditional civil engineering projects are of this type. Projects depicted below are good examples for illustrating the four GMPP categories. First category, transformation. HM courts and tribunal services reform can be listed under this category. The Columbus program can be listed under the ICT category. East-West Rail can be listed under infrastructure and construction category. And the Wildcat program that provides 62 helicopters to the British Army can be listed as a component of military capability. Without a doubt, engineering disciplines has the tightest linkages between applicability of project management. When we take a snapshot about the evolution of engineering, we see that civil engineering is the oldest field. When coming to modern world, we observe that software engineering is the youngest among the others. Therefore, it requires the most contemporary techniques to apply to. And when we mention engineering, I highly recommend you have a look to large-scale engineering case studies. I have listed four here. The first one is impossible engineering. The second one is supersized Earth. The third one is the abandoned engineering. And the fourth one is megastructures. Please do have a look at these and have a quick search on the net. This will really help you digest the application of large-scale engineering case studies. Having said that different disciplines require different approaches, it should be mentioned that a project's success is often dependent on competing criteria, typically expressed using a triangular model. On the bottom left, we see a triangular model that seeks a question for what is most important. In the middle, we see quality, and we see that the other three aspects of scope, time, and cost are layered around quality. And on the right hand side, we see that a triangular model that gives us decision guideline by just picking two. Rather, we decide a fast project, we want a cheap project, or we want a good project. We need to pick at least two of these parameters. Evaluating a project's performance is a very critical element of project management. IT projects are particularly prone to failure. Details of such failures in the public sector are well documented. Therefore, in this part of the lecture, I'll be putting my focus on IT projects. Standish Group, which is an organization that is working on IT project management, has published its benchmarks to define the success or performance of the project. IT projects are classified in three groups, such as successful, challenged, and failed. A successful project is one that is on time, on budget, with expected functionality. A challenged project is one that is late, over budget, or functionally incomplete. A failed project is one that has either been cancelled prior to completion or delivered and never used. In project management, the worst thing can happen is the failure of a project. But why do IT projects fail, as our focus is currently on IT field? The table below shows the top 10 classic mistakes reported by Nelson based on 99 retrospective conducted in 74 organizations over a period of 7 years. All of the top 10 were people and process related, as opposed to product or technology related. Classic mistakes in descending order of occurrence are: number 1, poor estimation and/or scheduling. Number 2, ineffective stakeholder management. Number 3, ineffective risk management. Number 4, insufficient planning. Number 5, short-change quality assurance. Number 6, weak personnel and/or team issues. Number 7, insufficient project sponsorship. Number 8, poor requirements determination. Number 9, inattention to politics. And finally, number 10, lack of user involvement. After describing the failure reasons in IT projects, we can give few examples from UK. The first one is from 2015. It is a UK e-borders perspective anticipated to be 8 years late after 830 million costs, including a 150 million legal settlement. Second one is a huge failure. It is from the year 2011, and it is an NHS 12 billion national computerized record system declared unfit and axed in favor of regional initiatives. The Libra project from 2008 is a 444 million magistrates case management system that is delivered late and treble original budget. In other words, it used 3 times than the original planned budget. In 1999, problems with new IT system for processing passport applications cost UK Passport Agency £12 million. And in 1993, the Project Taurus, which is the stock settlement system, scrapped by stock exchange after spending 10 years and £400 million. If you want to examine some more failure in IT projects, you can also have a check on Scottish examples of IT failures. I'll just name a few of them. Crown Office and Procurator Fiscal Service project. The other one is Registers of Scotland project, and the other one is Disclosure Scotland project. You can have a look and better understand the reasons of failure. To better understand why the failure rate is so high in software projects, we better make a comparison between software engineering with other engineering disciplines. I classified all other engineering disciplines as hardware and software engineering as software. So, software engineering versus hardware. Software is of poor visibility. There is very high complexity in software engineering, and there is high flexibility of perception. Also, they both have different performance characteristics. In software engineering, emphasis on skilled labor rather than materials, and also emphasis is on engineering rather than manufacturing. Another factor increasing the risk of IT projects failure is software is difficult to specify. Systems are developed to meet the requirements of users. There are operational users who physically operate the system, the supervisory users who may manage a group of operational users, and the executive users who are more concerned with strategic issues and long-term profit and loss. Different classes of users have different requirements. It is difficult to establish exactly what the system is to do, and having designed the system to convey the users how their requirements will be met by the system. Important features can be missing because it was assumed they would be included, or features are included because of the developers assumed that they would be useful, but the reverse proves to be the case. One approach to this problem is to produce a written specification saying that the system will do. Such written specifications can be very long, thousands of pages, so users are reluctant to scrutinize the specification, as the development team would like. Furthermore, it is difficult to write correct specifications in natural language, which is full of opportunities for ambiguity. The users are liable to approve the specification just to get it off. When the system arrives, the deficiencies are immediately apparent. Please do check the flow of figures that are on the slide. On the top left, you see how the customer explained it. Next to that, how the project leader understood it. Moving to next, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how the project was documented, what operations installed, how the customer was billed, how it was supported, and what the customer really needed. Another factor increasing the risk of IT project failure is software is malleable. When you build a bridge, you cannot change the foundations once they are laid. Software can be easily changed at any time during its development. Software is developed in units, which are combined into modules, which are integrated into a completed system. A change in one of unit may lead to have ramification on another unit. Uncontrolled change to a software system can bring development to a halt. A formal process of change control is highly required and needed. Another reason of software project failure is software projects are intractable. They are complex and they are hard to govern. Well, until this stage in this lecture, we defined what a project is, we made classification on projects, we defined project success and failure, and we examined IT projects as they are prone to failure. Let's summarize all and draw some conclusions. Compromises have to be made between cost, time, and project scope, but should never be made on quality. Criteria for classifying projects include size, cost, purpose, nature, and prior knowledge. Definitions of project success and failure depend on whom and when you ask. The main reason projects fail have been investigated, but projects still continue to fail spectacularly. Performance statistics are likely biased by distorted reporting of failures and underreporting of successes. The intangible nature of software projects can lead to problems related to visibility and perceived malleability. This is the end of this recording. Thanks for listening.